Assalamu alaikum. So let us start learning about the Z transform, and before we do that, let me just quickly go over what we did last time so that we last time we finished learning about discrete time Fourier transform, and I mentioned that in order to solve a problem, you should know the properties and the pair. So two things. So whenever you have you are given a question, find out which discrete Fourier transform pair will actually solve the problem, and then apply an appropriate property to solve it. Okay, so I give you this example where we tried solving this question 1 over 1 minus half exponential plus j omega, and this positive sign, and we know the pair is a of n, u of n is 1 over 1 minus a exponential minus j omega. So obviously this pair tells us that there is a change of sign. A question has a positive sign, whereas the pair has a negative sign. So, and we know that how to basically apply this property, which is flip in time is flip in frequency. So knowing this pair and this property will solve this particular question. Then I give you another example where we have exponential 4j omega divided by 1 over 1 minus 1 over 5 exponential minus j omega. Again, there has to be a pair and the property that should come to our mind, and the pair is same. A of n, u of n is 1 over 1 minus a exponential minus j omega, and we must always say a magnitude is less than 1. And the delay property, which says the delay in time is multiplication by an exponential. So we apply the pair and then we apply the property. So pair and property, basically then we get the answer to the question. So whether it is a question of backward finding inverse Fourier transform or a forward Fourier transform, we need to remember the pair and the properties. So then we started learning about Z transform. And Z transform, I give you the motivation of learning Z transform, that we need to find out the stability of an IER system. Whether we are modeling a system or we are designing a system, we need to know the stability, whether the system is going to be stable or not. And we know the criteria for stability is that your Fourier transform must be absolutely summable. So absolute summability is the property which is to be checked. Okay, and especially for the difference equation. And then I mentioned that given a difference equation, finding its impulse response, whereas impulse response of an IER system otherwise has no value for us. We are not really interested in finding the impulse response of an IER system. FIR, yes, because that's how you implement an FIR system, by convolving the impulse response with the signal. So that's the motivation, that we want to figure out the stability. So then we started learning about the Z transform, what Z transform actually is. And Z transform is primarily is we introduce a handler R to make a sequence converge. So even for the Fourier transform, only exists for stable system. So if you have an unstable impulse response like 2 of n, u of n, we know that its Fourier transform does not exist because it's a divergent sequence. So we we then introduce a kind of an handler R, and using this R, we try to make the sequence converge. So if there is a sequence that is diverging like 2 of n, u of n, then R can, any value of R which is greater than 2 can make the sequence converge. So we are in Z transform, we are not actually interested in Z transform itself, rather we are interested in finding the region of convergence of a transformation. There may be a sequence which is already converging, but still, because we have now introduced an R, still we need to find out the range of value of R for which an already convergent sequence will remain convergent. So we say, yeah, any value of R which is greater than 0.5 is going to keep the sequence converged. So this R primarily basically is something new in the Z transform. So the Z transform is kind of Fourier transform with this factor R. So once you have this R, it raised to the power minus n. So you combine this R minus n exponential minus j omega n to make this new variable Z. So Z transform formula emerged, which is A of n, Z of minus n, summation n goes from 0 to infinity. So knowing this much, then we establish the Z transform of most important sequence in signal processing, which is A of n, U of n. And the Z transform is A Z inverse A of n, U of n. So Z transform of A of n, U of n, and it came out to be 1 over 1 minus A Z inverse. And the important was that it's a region of convergence. So its region of convergence came out to be Z magnitude is greater than A magnitude. So then we established that whenever we mention the Z transform with the pair, with the Z transform pair, we must mention its region of convergence. In terms of Fourier transform, we were not mentioning the region of convergence. So we mention the region of convergence, and it is important to mention the region of convergence of the Z transform. Okay, and then so this is how you draw the region of convergence. So you plot a circle because it's a complex plane, and then you draw the region of convergence and say this. So for 2 of n, U of n region of convergence, Z magnitude is greater than 2. So you need to know that how you primarily plot that. So then so we said this is the most important pair, and then we also established that the Z transform is not unique. So for the uniqueness of Z transform, you need to mention the region of convergence. If you're not mentioning the region of convergence, then Z transform may have multiple values. For example, the Z transform of A of n, U of n, which is 1 over 1 minus A Z inverse, and minus A of n, U of minus n minus 1, both have same Z transform, 1 over 1 minus A Z inverse. So both have the same Z transform. So we need to, so both have the same Z transform. And then we started plotting these sequences, and then I proved that yes, both have same Z transform, but both have different region of convergences. For A of n, U of n, region of convergence is Z magnitude is greater than A magnitude. And for minus A of n, U of minus n minus 1, Z transform is same, but region of convergence, Z magnitude is less than A magnitude. So here region of convergence is outside this A, and here the region of convergence is inside this A. So then we started learning about poles and zeros. So that once a sequence H of Z is given, you need to know the roots of the numerator and roots of the denominator. Roots of the numerator are called the zeros of the system. And roots of the denominator are called poles of the system. This is almost where we left last time. So today let's pick up from where we left and start. Okay. So if you are given a sequence in h of z like 1 minus a z inverse 1 minus b z inverse, okay, or 1 minus c z inverse. So usually this is what you are going to get in h of z with a polynomial in the numerator and a polynomial in the denominator. So you need to find roots of the polynomial in the numerator and polynomial in the denominator. Zeros of the system and poles of the system. So zeros of the system are the roots of this, and it is the way we write the transfer function, like in terms of z inverse. We can always write in terms of z as well, but preferably you should write a transfer function in terms of z inverse. So if you put this equal to 0, it becomes 1 is equal to a z inverse and z is equal to a. Means writing a sequence, a transfer function like this. This is a root, this is a root, this is a root, and this is a root. So you don't need to do all the calculations because we know that these are the roots. So plotting is simpler. That once you are plotting, you plot a 0 like this. Okay, this is a. Whatever this a is the value of the root. So 0, you put a small circle for plotting the zeros of the system. Let's say b is somewhere here. So you have, this is value b. Okay, usually a and b are complex numbers. They are given in terms of r exponential j theta 1. So they are complex number and are given in terms of magnitude and the phase. So magnitude and the phase. So a complex number and that's how poles and zeros are written. And the pole is plotted using a cross. So pole is using a cross. So this is a pole. Okay. So this is how you plot poles and zeros of a system. So C and D are the poles. Poles are important because poles are important. They are in the denominator, and we will shortly find out that these are multiplied by y of n and previous values of y. So poles are more important than zeros for checking the stability of the system. So now let's now evaluate a transfer function like which h of n is a of n u of n, right? So we know S z transform is 1 minus a z inverse, where z magnitude is greater than a magnitude. Okay. So here the poles and zeros, because even if we write it like this, it is z minus a and z goes up. So this is our z0. So 0 of the system is at z is equal to 0 and pole of the system is at a. Let's say a is here. Okay. And the region of convergence is z magnitude is greater than. So you plot a circle and this is the region of convergence. This is a. Okay. Z magnitude greater than a magnitude is the region of convergence. So region of convergence we say is outside the pole. So region of convergence is outside the pole. outside a pole. So for the left-hand side sequence, like minus a of n, u of n minus 1. This sequence, if it is converging, this is the sequence. And if it is diverging, this is the sequence. So these are the two possibilities of this sequence, and we know that Z transform is same, which is 1 over 1 minus AZ inverse, but this time the region of convergence is Z magnitude is less than A magnitude. Okay, so once you plot it, it is plotted like this. So still pole and zeros are the same. So this is pole of the system. This is zero of the system. But the region of convergence is inside. So the region of convergence is inside the pole. Okay. So let's do an example to find a little more about this, but just keep the motivation in your mind. That real motivation is learning about the stability of the system. Until this point, we have no clue that how it is going to tell us about the stability of the system. So, example. So if you have any question, please ask. So, how you determine the region of convergence for left-hand side sequence? So I've told you that for a left-hand side sequence, region of convergence is inside the pole. So let's have a system with multiple poles. Let's say you have a sequence x of h of n. So we'll do both example. First left-hand side and then right-hand side sequences. So let's have right-hand side sequences, and right-hand side sequences 1 over 2 n u of n plus minus 1 over 5 n u of n. Okay, so this is a case where you have two sequences. Both are right hand side. So if you plot, this is half, so it is 1.5, and then you need to add another sequence which is this, because the negative sign means that for even values the value will be positive and for odd value will be negative. So you add them up together, so you get a sequence which will be this sequence. So Z transform is, the Z transform of half of n u of n. It is 1 over 1 minus half Z inverse, and then minus 1 over 5 n u of n. The transform is 1 over 1 plus 1 over 5 Z inverse. So for h of n, which is combination of the two, Z transform will be this plus this. So if you take LCM, why LCM? Because if you want to plot poles and zeros, you got to write them in this form. So this goes here, 1 plus 1 over 5 minus 1 over 2 Z inverse, and that's what you are going to get, okay? Because you have 1 plus this and 1 minus this, so 1 over, so this is 2 over 10 and 5 over 10, and so this is 1 minus 5 minus 2 is minus 3 over 10, I think so, okay, you can double check. 1 minus half Z inverse. So this is, so now you need to plot it. So if we plot this, let me plot it with the red pen. You have a 0 at 3 over 10.3. You have a pole at minus, sorry, it is at 310. Here, not here. 0 is at 310. One pole is at half. So 0.6 and 0.5. 0.6, 0.5. This is a pole. And one pole is at 0.2. So here, something like this. So you are going to have a pole at half, which is 0.5. Pole at 0.5. A 0 at 0.3, and another pole at 0.2, minus 0.2. So this is at minus 1 over 5, this is at half, and this is at 3 over 10, okay? So we know the region of convergence for this is Z magnitude greater than half. And region of convergence for this is Z magnitude is greater than 1 over 5. Okay. So this is equal to 0.5 and this is equal to 0.2. So Z greater than 0.5 and Z greater than 0.2, obviously the region of convergence is going to be Z greater than 0.5. So once you plot, plot is like this. Z magnitude greater than half. So for left hand side sequences, let me just for left hand side sequences, you need to plot all the poles to find out the so you plot all the poles. Let's say you have a pole, a pole, a pole at A, at B, and then at C. So you have 3 poles. Okay. It is not negative 0.5 because you need to take magnitude, and magnitude of minus 0.5 is 0.5, right? So we take always the magnitude. So we call that Z magnitude is greater than A magnitude. This is the formula. So it's not negative, it is always going to be positive. So it is greater than 0.5. So if you have 3 poles, and as Momina Wahid is rightly pointing out, it is greater than the maximum pole. For right hand side sequences, right hand side sequences, region of convergence is always greater than the maximum value of the pole magnitude. So the maximum value of the pole magnitude greater than that. So if in this case your region of convergence is going to be the outside the outermost pole, like this. Okay, so region of convergence is going to be outside the outermost pole. So region of right hand side sequences, region of convergence is outside the outermost pole. So this is important. For right hand side sequence, region of convergence is outside the outermost pole. Okay, slowly but surely we are going to learn that how we link it with stability of a system. Just remember that for right hand side sequences, the region of convergence is outside the outermost pole. What if you have left hand side sequences? So now another scenario is, what if we have left hand side sequences? Example is, if you have h of n which is minus a of n u of minus n minus 1 minus b of n u f minus n minus 1 minus c of n u f minus n minus 1. Okay, these are three left hand side sequences, and once you plot their poles are going to look similar. Let's say this is A, this is B, this is C. And we know that region of convergence of these three for the sequence is Z magnitude less than A magnitude, Z magnitude less than B magnitude, Z magnitude less than C magnitude. Okay, same, but now, so region of convergence will be now something which is less than A and less than B and less than C is less than A. So the region of convergence in this case will be this. So I can write region of convergence for left hand side sequences is inside the innermost pole. Innermost pole. So again, very important relationship. The region of convergence for left hand side sequences is, so this is very important. So now what if a sequence is, obvious question, a sequence is a left hand side and right hand side. So what are you going to do about it? Let me just remove this, just causing. Okay, so two-sided sequences. So the example of two-sided sequence is an h of n is equal to 1 over 2 n u of n plus 1 over 5 And let me put a negative sign for our convenience. U of n minus 1. So we know that it is a two-sided sequence. Okay. So the region of convergence and the Z transform we know for half of n U of n, this Z transform is 1 over 1 minus 1 over 2 Z inverse, where G magnitude is greater than half. For this we know this is a left hand side sequence, and this Z transform is also same, 1 over 1 minus 1 over 5 Z minus 1. Okay, and here Z magnitude is less than 1 over 5. Okay, so now its intersection is if something is greater than 1 over 2 and less than 1 over 5. So this is 0.5 and this is 0.2. Now it is saying region of convergence is inside this and outside this, inside this and outside this. Obviously, it's not possible. Empty set, there is an empty set, empty. So we say Z transform does not exist. Does not exist. Okay, because intersection, you are not finding any intersection. But on the other hand, if instead of this you have h of n, which is equal to minus 1 over 2n u of n and plus 1 over 2n, sorry, u of n minus n minus 1 and 1 over 2n u of n. So you make this as left hand side sequence and this as 1 over 5 right hand side sequence. Same question. Now we have changed the size, the sides of the sequences. Now the pole 0.2 is outside the pole, and for the left hand side it is inside the pole. And once you plot, now the region of convergence will be in shape of a ring. Okay. So for two-sided sequence, if your right hand side sequence is smaller and your left hand sequence, the pole is bigger, then it will shape into a ring. A Z transform is in form of a ring. It is outside the pole and inside the left hand side pole. So if we generalize this example, let's say there are 3 poles, A, B, C. And you are not told, and also remember that every pole means a sequence. So whenever there is a pole, means there is an exponential. There are 2 possibilities for this exponential. It may be a left hand side exponential or a right hand side exponential. If it is a left hand side exponential, it will be minus a of n u of minus n minus 1. If it is a right hand side exponential, its value will be a of n u of n. So a pole, because both will result into the same Z transform, which is 1 minus a Z inverse, same. Only the region of convergence for this will be Z magnitude is less than a magnitude, and for this will be Z magnitude is greater than a magnitude. Okay. So this is in a nutshell that if you are given a pole A pole does not reflect a unique sequence in time domain if its region of convergence is not mentioned. So you got to say there are two possibilities. One possibility is that it may be of result of a left hand side sequence or may be result of a right hand side sequence. So if it is a left hand side sequence, so it will come from a sequence like this. Z transform is this. Okay. If it is the result of a right hand side sequence, then sequence is this and region of convergence is this. So this question has many answers. Okay. This question, if only given you the poles, so you may say all these poles are represents so 3 poles represents right hand side sequences. If all these 3 poles represent right hand side sequences, then what is region of convergence? So all these are right hand side. So we know for right hand side sequence, region of convergence for this is greater than A, greater than B, greater than C. And as we have already established, it is outside the outermost pole. So region of convergence is going to be this. What if all of them you consider as left hand side sequences? Okay, the region of convergence is inside A, inside B, inside C. If you take the intersection, it is this. Okay. What if A is a right hand side sequence, but B and C are left hand side sequences? Okay, that's how I plot. A right hand side means greater than A, B and C less than. So we know region of convergence in this case is going to be in the shape of a ring. Okay, and now there is another possibility, A, B and C. What is that possibility? That if A is right hand side and C is left hand side, then is this ring. And then there are many possibilities where Z transform will not even exist. For example, if many possibilities where Z transform would simply not exist. For example, if A is left side and B and C are right side, so you can see that there will be no intersection, so no region of convergence. Similarly, if A and B are left hand side and C is right hand side, again no. Then if this is right, this is left, this is right, no. So you can figure out many possibilities where there will be no Z transform. Means there is no unique value of R which will make all these sequences, all these 3 sequences converge. So knowing this, that Z transform is not unique is a little problematic. So you got to figure out all the possible answers of a question especially given to you in the exam. So question is, what if there is A, B, C, D and A and D is right and B and C is left? So let me do that also first. Let me complete this. So there is a question, I'll answer it in a while. So but let me also write the sequences. So this particular question is a question where the Z transform can be written as 1 over 1 minus A Z inverse plus 1 over 1 minus B Z inverse plus 1 over 1 minus. So there are going to be zeros as well, but for reasons we don't worry about zeros, because stability, zeros does not play any role in stability. They do play a role in shaping the Fourier transform, but as they don't play any role in determining whether a system is stable or not, and our main concern right now is stability. So that's if this is the question, this is all, these are the poles which you got to plot, and then you start writing all the four possibilities. So this possibility, if I write the sequences will be A of n u of n plus B of n u of n plus C of n u of n. All are right hand side sequences. If this is the possibility where we are saying all the three sequences are left hand side sequences, so it is minus A of n u of minus n minus 1 minus B of n u of minus n minus 1 minus C of n u of n minus n minus 1. Okay, and similarly I know now you can easily write this one. Okay, this you can write right, left, left. So for right you write A of n u of n, and for left you write minus B of n u of n minus n minus 1 minus C of n u of n minus n minus 1, and similarly you can write that. Now a question is about if there are four poles, and please remember that if there are four, it depends on the position is A, B, C and D. A, B, C and D. Now the question is if there is A and D right hand side, okay, and B and C left, obviously there will be no region of convergence, because it says outside the pole, the rightmost pole, which is D, and it says inside. So outside this and inside this there is going to be no region of convergence. So answer is no region of convergence. What if, so the possibilities in this case, what are the possibilities? Let's just A, B, C, D. So one possibility is that all the sequences are right hand side. So two possibilities are guaranteed. All are right hand side, so the region of convergence will be outside the outermost pole. Okay. The other possibility is all left hand side, so region of convergence will be inside the innermost pole. And then there are possibilities that this could be this ring or this ring or this ring. Okay, three possibilities. So this could be this ring. This ring means A right hand side, B, C and D are left hand side sequences, one possibility. The other possibility is A, B, C and D. Okay, so you make possible rings. Other one is if this is the ring, then these two are right hand side sequences and left hand side sequences. Okay, and the third possibility is this is the ring. In the ring, there are three possible rings. So in this case, right hand side, right hand side, right hand side, left hand side. So if I conclude this, it says the region of convergence is outside the outermost pole of all right hand side sequences and inside the innermost poles of all left hand side sequences. So region of convergence will be a ring. A ring, it is outside the outermost pole of all right hand side sequences and inside the innermost pole of all left hand side sequences. For this to happen, all the right hand side sequences should be on one side, which is the inner side, and all the left hand side sequences got to be on the other side, which is, so that is only way of forming a ring. If this is violated, then there will be no region of convergence. So now we understand that if there are even more A, B, C, D, E, F, A, B, C, D, E, F. So if I ask you in a quiz or in an exam that how many possible region of convergences are there? One is all right hand side, all left hand side. So two are these. Then there are ring, one ring, second ring, third ring, fourth ring, fifth ring, 5 plus 2, 7. So there are going to be 7 possibilities. Okay. If this is the ring, it means A is right hand side, rest all are left hand side. If this is the ring, it means A and B right hand side, rest are left hand side. If C and D, a ring is here, so it means A, B, C are right hand side and D, E, F are left hand side. So you can just extend. So this is very important, like that we need to understand how to form the region of convergence. This is very, very important. Forming the region of convergence is important. Now, once we know that this is how we form the region of convergence, now is something that we can answer, at least summarize. So the only reason we compute a Z transform is to worry about the stability. And now we have established the region of convergences that for right hand side sequences, region of convergence is outside the outermost pole. Okay. Number 2, for left hand side sequences, region of convergence is inside the innermost pole. Number 3, for two-sided sequences, region of convergence is a ring which is outside the outermost pole of right hand side sequences and inside the innermost pole of left hand side sequences, region of convergence. For FIR, where there is no pole, FIR, region of convergence is entire Z space. Okay, there may be a pole at 0 is excluded or infinity is excluded. Okay. But otherwise, we don't even worry about the FIR sequences and worry about the region of convergences and finding stability and stuff. Another important fact is region of convergence cannot contain a pole. It may contain a 0, but it cannot contain a pole. And that's the reason we cannot say that this is the region of convergence, because it has a pole. A region of convergence cannot have a pole. Okay, so this is not possible, because a pole is something, if you put value 1 minus, for example, A Z inverse. And if Z is equal to A, so it is the pole. So at pole, if you put Z is equal to A, it becomes 1 over A, which is 1 minus 1, which is 1 over 0, which is equal to infinity. Why it is called a pole? Because the value of the Z transform at pole goes to infinity. Is jagah jab aayega, so if you are plotting at this, value of the Z transform will go to infinity. It will make a pole. On any side you come, it will make a pole. So it will start making a pole, जो बिजली का pole होता है. ठीक है? So it look like a pole. So the value of the Z transform is a pole. If you start plotting it, ऐसे लगेगा जैसे pole बन रहा है. So you say, oh, this is a pole. So this is why it is called a pole. And at 0, the Z transform becomes 0. Okay? If you put value of, and that's why they are called poles and zeros. So if you have, let's say you have 1 minus 2 Z inverse over 1 minus half Z inverse, and if you try to plot the Z transform to half, so guaranteed ke, sorry, 0. So Z transform value will be something like this, making a pole. And Z transform value will be 0 here at 0. Because once you put Z is equal to 2 in H of Z, so H of 2 is equal to 1 minus 2 over 2, 1 minus half into 1 over 2. So 1 minus 1, this will be 0. So expression will be 0. So that's why it is called zeros of the system, because it will make the transfer function equal to 0. It will hit the 0 and pole will hit infinity. So the poles and zeros of the system. And now we know that poles and zeros of the system, why they are called pole and zeros. So now we need to now move towards figuring out the stability of the system. Remember that stability is this. So you may ask question. We have a little time before we take a break. So if anybody has any question. So if there are no questions, let's take a 10-minute break and then we come back and continue from here. और एक क्विज के लिए तैयार रहिएगा. Okay, thank you.